Hello everyone. Welcome back to the part two of making deployments easy with containers and Google Cloud series. I'm super excited to have you all again on the stream. So let's get started. Let us just wait for 1 or 2 more minutes before other folks join in, and then we'll get started. So if you have joined the yesterday's stream, since this was a two-part series, then you would be able to catch up with all the seasons pretty easily. So all the resources that we discussed in yesterday's streams, you can get them on the resources link that I have shared yesterday. So let me just quickly pull up my screen. And if you are joining for the first time today, so that means that you did not attend yesterday's part. There is no need to worry at all. So all of our streams are recorded on Twitch as well as YouTube. So you can always go back and rewatch the recording. And also the concept that I would be explaining today, I'll try to make sure that you understand how it works as well, even though if you could not attend yesterday's session. So I'll make sure that you understand what is going on and how is different thing happening. But if you wanted to go deep dive and understand how different thing works, then you can also go ahead and watch the part two of the stream as well. Sorry, the part one of the stream that was held live yesterday. So the recordings are up there. So let us go ahead and start with the part two of making deployments easy with containers and Google Cloud. Before that, for our new viewers, let me introduce myself. I am Sagar and I'm a coach at Major League Hacking. And professionally, I build DevOps solutions. I work for an AWS partner company, so I mostly work around cloud and DevOps solutions. And before we get started, I'd also like to wish you all a very Happy New Year and Merry Christmas, which is due tonight, as well as New Year is coming on few days. So wish you all happy holidays. Also, a fun fact that Nepal is currently in the year 2018. That's the country where I am from. So we are far in the future. So people call ourselves as people from the future because we do not follow the Georgian calendar. We have our own calendar over here. So that's just a fun fact that I wanted to share with you all. And you can always connect with me on my Twitter, LinkedIn, or Instagram. I'm active over there. So if you would like to ask any questions or stay connected with me after the stream, then please feel free to do so in these social handles. Again, welcome everyone to what I call as the container lane because we have been discussing everything about Dockers, how you could package your applications into a single unit and then deploy it to Google Cloud using Google Cloud Run and the different Google services. And that is what I call as a container lane. And I'm super happy to have you here. Please make sure that you bookmark the specific link. This is the uh, uh, resources link that contains all the things that I will be describing in the session. Also, it contains every notes and resources from yesterday's session. So, as Abul Hussein has mentioned that they are watching this for the first time. So, this is the resource that you can always check out as it contains all the information from yesterday's sessions as well. And again, I would like to mention that I will try my best to describe everything that I do today so that even if you did not watch yesterday's stream, you would be able to catch up with at least some of the things that I was talking about. So do not worry if you're watching this for the first time. Let me go ahead and bookmark the link that I have just shown you on the slides for you all. I'll put that in the comments and highlights so that all of you can uh, pin this or bookmark this link and get all the resources. So that's the link containers that MLH, and I'll make sure that it's up on the stream as well. So that is all good. And next up, like we discussed, the breakdown of the session. So these are the things that we covered yesterday. So we introduced Docker, what Docker is, and why was there even a need in the first place to have Docker containers. So we discussed about Dockers and the importance of Docker containers, and then we looked at different Docker commands and some of the use case for the basic Docker commands, such as getting the images from Docker registry, pulling up the images, creating our open containers, running the Docker containers, getting some of the logs and all those things. So we looked at all these Docker commands, and then we also saw how we could create our own Docker image for the application that we have written. So we saw how we can use Dockerfile to create our own application image. We also saw how to use multi-stage build to improve our image caching layers and to speed up the image build process. So we saw those practices as well. And then we ran this Docker locally on our machine. Remember, we used Docker Desktop to install Docker on our machine. And once we built the image, we ran it locally on our machine. And then we tried to push this image to Google's artifact registry. So that's a service from Google Cloud, which allow us to store the Docker image that we build into a private registry so that we can use it for our applications when we are about to deploy them to Google Cloud Run. Also, if you want to share the image with other people, so Google Artifact Repository also allow us to do that. So that is all the things that we did yesterday. And talking about the things that we will be doing today. So we will be first setting up a MongoDB database on Google Cloud. So we will be configuring a database for our mean stack application. Remember, we cloned a mean stack based application. So mean stack, for those of you who do not know, is a stack popular, and it's a popular stack made of MongoDB, Angular, and Node.js. MongoDB is the database over there. Express is the Node.js runtime, and for the front end, Angular is the front end framework like React or Vue.js. So that was the stack that we took, and we tried to containerize the client as well as the server side source code. And then once we containerize it, we pushed it to the Google Artifact repository. So today we will be first setting up the database for our backend, and then we will configure and run our containers on Google Cloud Run. We will ensure that the database URL and the configuration is set up correctly. And we will also set up an automated deployment with GitHub so that whenever there is any change to our code, such as in the front end or in the back end, we do not have to manually deploy these containers, because there are certain services in Google Cloud, such as the code build, which works with GitHub, and that automates the entire deployment process. So all of that happens automatically, and that's something magical that I would like to show you all towards the end. And finally, if we get some time, we will also see how we can map a custom domain name. So if you happen to have a custom domain name for that application, we'll also see how you can map a custom domain name to the application that you have deployed on Google Cloud. So these are the things that we'll be covering today, and we'll also see some of the best practices when we do the demo. So let us get started, and let me quickly pull up my VS Code over here. Okay, so this is this was one of the sample application that we used yesterday. So let me open up the mean stack application. So this was the one that we used for the first demo, but since we are trying to deploy our mean stack application, let me go back to that one, and that would be mean stack example. So this is the one, and I'll open this one actually. And let me close the earlier one. That was the wrong project. Okay, so this is the one that I want to show you all. Let me quickly close all of the tab, and there we go. So this is the application that we saw yesterday, and we tried to containerize it. I'll also quickly show for our new viewers who just caught up today. So this is a simple mean stack application. On the server side, we have the Node.js and Express framework. It's using TypeScript as the programming language, and you can see the different dependency that our backend server uses over here. And you can see that it is using MongoDB for our database and Express as the backend server-side framework. And for the client, this is the Angular application. And the Angular application contains the front-end code. All the codes are inside this SRC folder. And you can see that we have a Docker file in both of the project folder. So Docker file inside the server folder. This is what we use to build our backend image. And remember, we pushed this image to Google Artifact Registry yesterday. And likewise, we also have a Docker file for client, and we will use this Docker file to push our front end or the client side image to Google Artifact Registry as well. So yesterday we completed up to the server side part where we built an image for our backend that was the Node.js server, and then we pushed it to Google Artifact Registry. So let me quickly show you that as well. So let me quickly pull up the Google Artifact Registry. So right now I'm in the Google Cloud Console. So for folks who are just joining in, so we are right now in the Google Cloud Console. You can sign up for Google Cloud using the links that I have provided in the description. So that contains all the resources for our session. I can quickly show you that as well. So this is the session resource that will link you to the page. There's no some specific page, and here you will get all the prerequisites that you need to follow along the session. So we completed all of this yesterday. We installed the Docker. We also got our Google Cloud account, and you can see that I'm inside the Google Cloud console over here. We need to have Git and GitHub also in our hand, so that is also done. And for the user cloud CLI, which we installed yesterday, we also need to have Python installed on our machine. So that is all that we did yesterday. For the part one, like I said, we covered up all the Docker commands yesterday. And then we created the image for a sample Node.js application. And later on, we cloned a mean stack application. And then we tried to create an image for our front end as well as back end and pushed it to the Google Artifact registry. So we did all of that yesterday. Remember, in order to uh, push the image to Google Artifact Registry, we need to first initialize the Google Cloud on our terminal, and then we need to authenticate our terminal with the Google Cloud Artifact Registry. That is how we did over here. And then we need to tag the Docker image that we built into a specific format because Google Artifact, or for that matter, any other cloud service provider requires us to tag the Docker images in a specific format. And this is the format that Google Cloud support. So we need to provide a location and then followed by the specific path, and we need to give a project ID, repository name, and then finally the image name with a specific tag. So that is what we did yesterday. And then we used the Docker tag command to tag the image. And finally, we used Docker push command to push the image to the artifact registry. And you can see that we have the image right over here, and we pushed our image into the mean app repository, and you can see that we have the image for both client and server. I deployed client earlier to this demo, but yesterday we deployed only the server side uh, image, and I'll show you how to deploy the client side in just a moment. You can see that we have two different images, one with version of 1.0 and one with no any specific tag. That means that it was not tagged. So that will be default to latest tag if we do not specify any tag. So we have two images over here. So before we go ahead and try to create a MongoDB database for our server, I want to highlight you all that there is a specific requirement if you are uh, trying to build the image from Windows or Mac OS operating system. So yesterday, if you see that in the Docker file, we did not use the dash dash platform equals to Linux slash AMD4 command in our Docker file. That is because when you use Mac OS to build the Docker images, it uses the ARM-based architecture since Mac, especially the M1 and M2 chip-based Mac operating system uses the ARM-based architecture. So there might be compatibility issue when you try to run the Docker image built out of these machines into Google Cloud Run. So that is something that I faced yesterday. So if you are using Mac OS or if you're running a Mac M1 or M2, then please make sure that you include the dash dash platform equals to Linux slash AMD 64 in the from instruction in a Docker file. And this will allow us to build the Docker image based on the Linux architecture, which is compatible with the Google Cloud Run. So that is one of the common issues that people might face when deploying their custom Docker image into Google Cloud Run. So please make sure that you do this. So I think what will make this easier is to use the repository that I have provided for you all. So I have gone ahead and created a GitHub repository which contains all the um, code from the Minstack application, all the client as well as server side codes, including the corrected Docker files, as well as I have added some additional Docker ignore files as well. So we'll see that in a moment. So please go ahead and clone that. So this is the repo that I have used, and you can see that in the repo I have corrected all the test routes and mentioned everything. And you can see that if I go to server over here and see the Docker file, it has the platform command as well. So this will ensure that the Docker image will run on Cloud Run. So make sure that you go ahead and uh, clone the Docker repository as well. I have also highlighted the link on the screen for you to clone along. So let us go back to the Docker file here. So if you are facing such issue, or if you have built the image out of Windows or Mac-based operating system, it's very good practice to just rebuild the image and repush the image. So I will just do that for you all here live itself. So also, I want to highlight you all before I build the Docker image, the importance of Docker ignore file. So we have a Docker file over here that is used to build the image that we will see in a moment, but we also have a .docker ignore file. So for the folks that are already aware about the git ignore file, it's similar to that. And the folders and the file that you specify in the specific file. So for example, I have mentioned about the node module. So if you're trying to build any node project in your local machine, there would be the node modules folder, which contains all the dependency when you run it locally. So if I were to uh, run this application locally, which I'm not going to do because we are just trying to deploy everything using Docker, we do not need to have Node.js installed on our machine. But let's say if I were a developer and if I was using Node to install the dependency, whenever I would do npm install, which is a command that is used to install the packages, or yarn install, that's the another package manager for Node.js. There would be a Node.js folder inside the server folder, sorry, the Node modules folder, and that contains a lot of dependency which we do not need because we can install that dependency in the Docker file build process itself. So here you can see that we are copying the package.json into the Docker container and we are installing the packages again. So that means that the Node modules folders is not needed when we package a Docker image or when we try to deploy the application, because we would do that inside the container image itself. So we can have those files in the node Docker ignore file, and this will ensure that those folders or files are not present in the Docker image. So you can see that we are putting the node modules folder as well as the .env file. The .env file contains the MongoDB Atlas URI. So this is the connection string of our database. If you have used MongoDB before, you would know about this. It's just a link to the database that our server can use in order to connect with the database. So if you are using MongoDB, so we do not need to also have any of the environment files or secrets into our Docker image. So we will also put that on the ignore list. So I just want to make sure that you are aware about the Docker ignore as well. So if there are any files and folders that you do not need while building the Docker images that you need to copy from the host to the container, you can just simply put that in the Docker ignore and it will not use that in the build process, because we are, again, like I said earlier, installing the packages from the Docker instructions itself. So let me go ahead and build the Docker image. Again, I will cd into the server, and here let us build the image. I will run the docker build command, and we can give a tag, and here I will give a tag of min node server, and I will give it a tag of 1.0. So remember, this is the image name and this will be the tag for the image. And likewise, since I'm already inside a folder which contains the docker file, I can just mention the build context as dot. So let me go ahead and build the image, and you can see that the build process is running, and let me wait for that to complete. In the meantime, if you have any questions, let me know in the chat, and I would be more than happy to answer your question. So let us wait for this to complete, and once we have this, we will also create a MongoDB database on Google Cloud using MongoDB Atlas and make sure that our backend is running smoothly before we deploy our client or the Angular application. So you can see that the build process is complete. So if I now do Google Images, you can see that I have the mean node server image right over here. So the image is right there, and that means that now I'm ready to tag this image and push it to Google Cloud. Again, I will highlight the resources link for you all so that you can all follow along while I showcase the demo. So in order to do that, let me clear this up just for a second. So I'll need to use the docker tag command, and remember that we need to use the specific format. So first, after the docker tag, we provide the name of the image on our own local machine. So we had the image name as main node server 1.0. So that was our own image name. And then we need to provide the specific format for our cloud registry. So if I go back over here, you can see that it follows the specific format. This is the repository link, and then we have the project ID, and this is finally the repository ID. So if I copy this, you can see that, let me go back to VS Code. Uh, Before that, let me just tag that and I'll explain what I just did. So you can see that on the right hand side up to this is the format that is required by the Google Cloud Registry for us to follow whenever we want to push the custom images from our own machine to Google Cloud Registry. And we just copied this from the Google Artifact repository. And after you copy this, we need to also provide the local image name that we used. So remember, this was the local image name without all the specific prefix that Google Cloud Registry required or the Google Artifact Registry. So this is exactly the prefix that we copied, and after the slash we have the exact same name that we used locally for the image. So it was mean node.js server uh, 1.0. So that is what we use. Let me just cancel that. So now our image is tagged. So now if I do images again, you can see that we have this specific image with the prefix that the Google Artifact Registry requires. So now we have properly retagged our image in the specific format that Google Cloud Registry requires. So we are good to go ahead and push our images to Google Artifact Registry. So let me go ahead and do that. Docker push, and I will use the specific command. So this is the image name now, and here is the image name with a specific tag. So this will push the image for our server into the Google Artifact Registry. So let us wait for this to complete. And if you are following along, please let me know if you have any difficulty in following along or if you have any questions. I would be more than happy to answer the questions. So you can see that the push process is already complete. Again, remember that if you are not able to push to the Google Artifact Registry, most likely you are not authenticated to the Google Artifact repository. So for that, like I mentioned yesterday, you can follow along the guide that I have provided in the resources page. So you need to install the uh, Google's Cloud CLI SDK. So you need to go ahead and install the Google Cloud from the specific link. And once you install that, you can go back to your terminal and then do Zcloud in it. And then once you do Zcloud in it, it will ask you for some initial configuration. And once you configure that, you can use the Zcloud auth command. And if you are wondering where did I get this command, you can get this command from the uh, Google Artifact Registry itself. So you can go to the setup instruction, and from here you will be able to get the authenticate command that you can copy and paste in your terminal to authenticate your own terminal to the Google Artifact repository. So that is all done, and you can see that I have pushed the image version as well. You can see the latest one was created 1 minute ago, and it has the tag that I just used of 1.0. So we are just good to go and run our backend container. But if you look ahead and see the code for our backend application, so I also want to show you that. So let me just quickly close this up. And if I now scan the backend code, you can see that on the .env file, it is expecting an Atlas URI environment variable, right? So this is the URL for the database that we need to create. So since now we are not creating any database, so the application would not run, or the API backend which is created using the Express here would not run because it does not have a database to connect. So let us go ahead and create that database in Google Cloud using MongoDB Atlas. So I'll come back to Google Cloud and let me open up the another instance of the tab over here, and I'll search for MongoDB over here, and let you can find MongoDB Atlas in the products and page once you search for it. So go ahead and click on that. And here first, if you're using this for the first time, you might be seeing enable this API, or you go ahead and enable that API first. And once you do that, you need to sign up for a MongoDB Atlas account. It might redirect you to the MongoDB Atlas screen. So go ahead and sign up for the MongoDB account. I have posted screenshot for the reference. Since I have already signed up, it's not asking me to sign up again. But if you're doing this for the first time, it will ask you to create an account in MongoDB. And then once you create your account in MongoDB, you will then be able to come to this page. And from here, you can click manage on provider. And it will redirect us to a MongoDB Atlas page, as you can see over here. So let me go ahead and do that as well to follow along with you all. I log into the account. uh, I'm using the same Google account for both the Google Cloud Console as well as MongoDB. So I should be able to just simply log in with the MongoDB Atlas. And MongoDB Atlas will allow us to create a MongoDB database on cloud, and that will connect to our server or the Node.js application that is running on Google Cloud. And that makes both the things very easy since both our backend server as well as database would be running on cloud itself. So uh, let us go ahead and create a database first. So first, by default, you will have the project 0 as your default project. And in the database, go to the database section. I have already created a simple database, but I'll show you how you can do that as well. So click on create. And once you click on create, you will be greeted with different options over here. Let me zoom that for you all. Uh, Go ahead and do the global go ahead and select Google Cloud as your cloud provider because we are using Google Cloud for the demo. And let us go ahead and see the different options over here. So you can create a serverless as well, but that would cost you some money. But I want to show you the free option that we can all get. So if you go to the share tab, uh, you can see that we can create a database in different regions. Please select the one that is nearest to you, as that would reduce the latency of the request and the response. So go ahead and select the region that is nearest to you. Since I am based in Nepal, I will select the Mumbai one, and I will select Google Cloud as the uh, cloud service provider. If you go to shared and then select the cloud service provider and then select the region, you can see that the pricing is set to free. So that will allow us to get a free shared database that we can use for the demo purpose. But you can see that I'm getting some notice that my project has already a free cluster which is already up and running, and MongoDB allow us to only have one free cluster per account. So I'll go ahead and cancel this. But if you're doing this for the first time, then you would be able to create a free database over here. So I'll go ahead and cancel this, and I'll just go to the database that I just created earlier. So this is the database that I created earlier, and this is a free database which is up and running. And if you go to the different options over here, I can see the connect options right over here. So go ahead and click on connect. And once you go ahead and click on connect, you can select the drivers. And from the driver, make sure that you are using the Node.js driver over here and you use the latest version. So here you will be able to see the link that you need to copy for your database. And remember that when you create a database for the first time in MongoDB, like the way I showed you, so I just showed you earlier that you will create a database by going to the database section over here and then click on create. And once you click on create, go to shared, select Google Cloud and the reason, and it will ask you to also create a user and a password. So please remember that user and password, as that is super important, because we will need to pass that database username and password in the URL itself when we configure our cloud run. So we would need to have that database and password, username and password super safe. So please go ahead and copy that as well when you create the database in MongoDB. And then I can go to connect again and driver. I will also copy the link that is provided over here. So I'll just copy the link from here. And now what I will do is I will go to the Google Cloud Run service. So remember that we have already uploaded the image to artifact registry. So now I will come back to Google Cloud and we'll use the service that is used to run containers. So that is the Cloud Run service. So Cloud Run is a serverless service that allows us to run containers on Google Cloud. And you can see that I have already gone ahead and run the containers for us, but I'll also show you the process again so that you all can follow along. So the first thing that you need to do is to create a service. So go ahead and do that. So let us go ahead and create the service, and then we need to select the container image that we just deployed. So remember, we deployed the image for our Node.js application, right? So this was the image that we deployed. Remember that from the VS Code terminal. So we just pushed the specific image to Google Cloud, right? So let us go ahead and use that image to run this container. So I can click on select, and from the artifact registry section, I can select the main application and we push the image for our server, and that was the image that we just pushed 7 minutes ago, right? So I'll select this image, click on that and select. I'll keep it the service name. So this is the service name. I'll write MLS to just separate it from the other containers which are already running. And again, here you can select the region. Please select the region which is nearest to your geographical location, because that will reduce the time for request and response time, and that will improve your speed on how much fast you can connect to your application. So make sure that you select the region which is nearest to you. For me, I'll select the Mumbai one. I'll go ahead and select Mumbai. And for the CPU allocation and pricing, please select CPU is always allocated. So the difference between these two is that if you select the first one, the Cloud Run will only start or warm up once the users or the traffic starts to come in your website. So let's say for 10 hours there was no one trying to access your website, then the Cloud Run would automatically analyze your traffic and shut down your Cloud Run service. But if you select the second one, which means CPU is always allocated, which it means that the Cloud Run service would always be up and running no matter the traffic on your website. So that will allow us to access our website at any time that we want. If you use the first option, you are still able to access your website, but it might take a few more time to start the Cloud Run service if you are accessing it infrequently. So if you are just trying to make sure that your application is up and running and you are quickly able to access your application, then make sure that you select the second option, which is CPU is always allocated. And for the auto scaling as well, that's the number of instances of your application. So let's say the traffic in your application uh, is 5 users per day, right? Or 5 views per day, I would say. That might be the case when you're just testing it out. But let's say tomorrow your application grows suddenly and now you start to get a lot of traffic, right? So once you start getting a lot of traffic, Cloud Run has this really cool feature to automatically scale the number of instances so that uh, your application can meet the demand of the traffic and your application would not crash. So this is the auto scaling feature, so that the application, let's say it was running one instances of the application earlier, and now your traffic has increased, so it will create multiple instances of the application, so that now the traffic is being able to handle the application as well. So that is what auto scaling means, and I'll set the minimum number of instances as one, as I do not want my application to go down at any moment, and the maximum would be default as 100. So remember that you might need to tweak this around depending on your traffic, but make sure that your application is able to handle the traffic that you expect. And for ingress control, since this is a web application that I want to be accessed by everyone, I will keep it as all. But if this is for a specific case where you just want to expose these backend API to specific microservices or certain applications, then you can also select an internal application type. But that is a bit advanced concept with out of scope for this stream. So we'll just allow direct access to our service from the internet itself. And like I said, since this is a public API or a website, I will click on allow authenticated invocations in the authentication type as well. Now, for the containers volume and networking part, so this is a really important part because we are creating different resources for our container itself. And right now it is allocating 512 megabytes of memory for my container uh, for each of the instance. So remember the auto scaling part that I just mentioned earlier, right? So one instance will have 512 or half GB of memory and one virtual CPU allocated. But let's say that does not meet the demand of your traffic, or your application is using a huge amount of resource, then the auto scaling will kick in and it will add more instance as needed, so automatically. So that is a really cool feature. You always want to turn that on. And on the next thing, we have the variables and secrets, and this is super important because remember, if we go back to the code uh, over here, I'll quickly pull the VS Code. You can see that our server is expecting Atlas URI environment variable, right? And the value of the environment variable is the MongoDB URL that we just saw from MongoDB Atlas. So let us go ahead and put this environment variable in the configuration tab, because if you see that when we build the Docker image, the Atlas URI value for the Atlas URL is just a dummy or a fake one, right? Because we don't have a username over here, we don't have a password over here. So that means that the backend or the server side would not be able to connect to the database. So we need to provide the actual database URL in order for our backend application to connect with the database, right? So we'll just copy the environment variable name from here. So that would be Atlas URI. So I will copy this and let me go back to the browser. and I will add the environment variable. The name would be Atlas URI, and the value for this, as I already showed you, is from here, right? So let me copy that as well. I will copy this one. I'll come over here and I will paste the value over here. But please remember that we need to also change the username and password, right? So the username that I set during the creation of the database was Saga, and you can check that from the database access tab as well. So you can see the username that is available for an application. So I have two users for my database. You can add new user, delete user from here itself. So this is the username that I used, and I'll also copy the password. I have stored that password in the in my password manager over here. So not that one. I believe. Let me create a new. See the password, and actually let us do one thing. Let us edit a new edit the password to create a new one and use that one. Okay. So let me auto generate the new password, and I'll just copy this specific password from here, and then I will use that password in the password tab that is mentioned over here. Mm, equal to was not over there. So now we have the correct value for our database, right? So this is the user, as you can see from the MongoDB. My user is Sagar, Sagar, and then the colon, which separates the username and password. And after that, I have pasted the password that I just created, right? So let me go ahead and save that as well because I want the database password to be updated. So now I can go ahead and click on done. So everything is done over here. You can also check some of the other options over here, such as different networking and security options if you want to learn more about how you can configure Docker container. But for our use case, this is enough. So remember what we did till now. So we selected the container image that we just pushed from our own mm, PC, and then we built this image, we posted to container registry, and then we selected that over here. We gave it a name, we selected the region, we kept the auto scaling as minimum number to 1 and the maximum to 100. We allowed all the ingress control and authentication as allow on authenticate invocations because since I want this to be a public API. And then we set the container port, and you might be wondering where did I get this container port, right? So the container port is 8080, but I'm pretty sure that's not the correct one. Let us see what the correct container port is. So if you go to the Docker file, you can see that the container is being ran on port 5200. So that just happens to be the container where the application is running, the Node.js application. It might be different for your application. So normally a Node.js application also runs on port 3000, whereas if you are using the front end React or any other framework such as Angular, they would be running on different ports. So for our backend over here, you can see that on the Docker file, it has exposed 5200 as the port. So that is the port where the application is running. So let me go back to the container registry and Cloud Run, and I can put the container port as 5200 because that is where the application would listen to all the requests. So we have specified the container port where the container would be running. We have given it the environment variable with the MongoDB URI. So we should be good to go. And I'll just click on create and let us see what happens now. So this is creating the uh, mean Node.js server over here. And you can see that the deployment is complete and you can see the green check mark over here. If I go to logs, you can see different logs of the application right here itself. And you can see that the server is now running at localhost 5200. So but now it's running on Google Cloud Run, and here you will be able to get the public URI for your API that we just deployed. And if I go to the URL over here, you can see that we are inside the container for our backend, and our backend does not have a slash or the root endpoint, so that is why it's not able to access that. But let me go ahead and go with the root path that exist in the database or the API. So that is the slash employees. And you can see that we get some results from the API, right? So that means that our backend is up and running. You might be wondering who inserted this data, right? Because I created this database earlier and I inserted some of the data. So that is why it is able to get the employees ID, name, position, and all those things. But if you are running this for the first time, your database would be empty. So you'd just be getting an empty array over here. So this means that our backend API is running fine. You can see everything is all good. We can get the metrics. The URL is all done. So the next thing that we need to do is to copy this URI because we need our front end to be able to connect with our backend. And this is the backend URI that we will be using to configure our front end. So let me go back to the VS Code. And remember that what we have done till now. So we have created a Docker image for our backend that was the Node.js application. We deployed the Node.js application to Google Cloud Run. We also created a database for our backend. So that was the MongoDB database. And we configured our container to use the environment variable that was Atlas URI. And we inserted the value from the MongoDB Atlas into the container. And now our container for our backend is running smoothly, and it is now ready to accept all the traffic from our client, which is the front end. So let us go ahead and configure the front end now. So I'll just collapse the backend folder, and now I will open the client folder. And here you can see that we have the SRC folder, which contains the front end logic. And if you go inside the app folder inside the SRC, and if you go to employee.service.ts, so that is where you need to provide the link for your Cloud Run application. So let me go ahead and do that. So this was a sample Cloud Run link that was already present before. So if you are doing this just locally without using Docker, or if you are just trying to deploy this locally and not to Cloud Run, you could just uncomment the private URL from here and you could run it locally. But since we have already deployed our backend to Cloud Run, we can now get that URL and replace the URL over here. So I'll just collapse that and let me go back to Cloud Run. And this is the URL that we just deployed, right? So I'll just copy this one and I will come back over here, and now I will paste this over here. So you can see that I have added the URL of the backend inside the path that expects the backend URL. So this might be different depending on your application. So if you are using React or any other framework to write your front end, so you'd need some path where you can connect to backend, right? And normally it would be like this in the way it is written over here. So you would normally be using localhost and port of your backend to access the application locally. But when you deploy it to a server, you can use the server link or the server IP to get the uh, a specific endpoint for your backend. So I have replaced that one. And now I am good to create the Docker image for our front end as well. So remember, we just created the image for our backend earlier. Now we will create the image for our Angular application, since we have already configured a backend API path, right? So we have deployed the backend to Cloud Run and also configured that to connect with our MongoDB. So now we are good to go ahead and create the front end image. So I'll just go back to the client folder, and remember that the client folder also has a Docker file, and I am using the platform equals to Linux slash AMD4. Since I am creating an image out of a Mac operating system, you need to have this flag, and you can get this flag from the sample GitHub link that I have provided in the comments as well as in the resources section, which you can find. I will also put that up on the screen so that you can clone and work along. So let me go ahead and build the Docker image again. So I will build the Docker image. That would be mean node client, uh, node.js client 1.0, and I'll keep the build context at dot since the Docker file is inside the client folder itself. So this will create the client image. Let us wait for it to complete. And then once we build it, we need to follow the same steps again. That is to tag the image into the Docker registry format, and then we need to push the client image as well. So let's wait for this to complete. In the meantime, I'm more than happy to answer any questions if you have. So fire me up with all the questions that you might have. So this might take some time because it needs to build all the layers that we talked yesterday, right? In the meantime, I want to know how is Christmas coming up for you all. It's just 5 hours from the time zone that I'm streaming right now, and I'm super excited for Christmas as well. And I hope you all are. So let me know how much you are excited for Christmas as well. So let's wait for that to complete. In the meantime, let us see if our backend is running fine. So this was the front end and backend that I already deployed before this stream, but discard that for now as I want to show you all the process from scratch. So this is the backend that we deployed, and you can see that it is running. You can get logs, metrics, and everything over here. I think the image should be built by now. Nope, it's not. It's taking some time, so let's wait for that to complete. Mhm. So let us wait for that. Okay, so looks like the build process is about to complete. As you can see that it's building the production build, which is in the stage over here. So all of the steps were completed. So right now we are in the second stage of the multi-stage build. So let us wait for this to complete. And that should be done in no time now. Mhm. Let me know if everything is clear to you all the font size and everything. Otherwise, I'm more than happy to just zoom it for you as well. Let me add some background music while we wait for that. It's taking some unusual amounts of time to build this image because I'm pretty sure it did not take this much of time earlier. Let us wait for this to be done. But let's do one thing before that. While the image for the front end is being built, let us set up an automated deployment for our backend, right? So I mentioned about we can set up an automated deployment using GitHub and Google Cloud Build, right? So for that, what we need to do is to push our image to a GitHub repository. So please make sure that you do that first. I'll just open up another terminal over here. And since I have already gone ahead and post this entire folder to GitHub, you can find the link over here as I can show you in the screen as well. So this is also in the GitHub repository. But if you are not, if you have not pushed this to your own GitHub repository, so make sure that you go ahead and do that. For that, you can do two things to push to GitHub repository. First, you need to remove the origin because it contains my origin at the moment. So if you do git remote dash v, you will see that it is linked to my GitHub account. So for that, you need to do git remote and then remove and origin, which I'm not going to do because I don't want it to be only for my account. But if you are trying to upload this to your own GitHub, you need to remove the origin, and then you can add your origin with the repo link that you have just created. So go ahead to GitHub and create a new repository. So you can create a new repository by going to GitHub, and under the repositories section, you can create a new repository. And once you create a new repository, you would get the GitHub link, and please go ahead and add that link over here. And once you add the remote, you will be able to just use the git commit and git push command. So just add everything, git add dot, and then you can commit their changes and then push to your GitHub repository, because we would need your code to be on GitHub before we complete the automated deployment. Or you can also use the source control that is available from the VS Code itself. So once you add the remote origin, you can also push all the code to your repository right from here itself. So you can just pass in the messages and then click on commit, and then to try to push it to your GitHub account directly from here as well without going through other commands. So before that, let me see if the build is complete. And here you can see that the client side build is now completed. So I can now go ahead and tag the image according to the format that I need. So let me see the image first. So if I now go to Docker images, here you can see that the image is built. So the image name was mean Node.js client and with tag version 1.0. So I'll just clear this up, and then I'll just use Docker tag again. That was mean Node.js client, right? Uh, Let me just paste that instead of typing. And then the version was 1.0, and then I would need to follow the format provided by the uh, Google Container Registry. So inside the registry, let me go back to mean application, and then I'll copy this. I'll come back to the terminal and I'll paste this again and mean app, and then I will copy the source image name over here. I'll paste this and we should be good to go. So We have retagged our local image into the format which was required by the Google Artifact Repository. So this was the image name that was present on our machine, but since Google Artifact Repository requires us to have this specific prefix, which you can get from the artifact repository itself. So we have retagged it, and now I can use the docker push command to push this image. So I'll just copy the image name over here, and now this will push the image to our artifact repository. So let us wait for this to complete. And once we complete this, we would be able to run the container in Google Cloud Run. So you can see that the push process is complete. So I'll come back to Google Cloud, and if I click on the main application, let us go ahead and see that in the main application, we have the main Node.js client, right? So which was created just now. So this is the image that we just pushed to Google Artifact Repository. So let's go ahead and use this image to let's go ahead and use this image to run the container itself. So let me go ahead and do that. So I'll come back to Cloud Run again, and now I'll create a new service. So in order to select the container image, we can click on select, and under the artifact repository. So thanks, Rosmi, that you are following along and everything is clear to you. So let me know if you have any questions. I will just bring back the resources link again. So you can see that we have different images over here, and let me go ahead and select the main application that I created. And the one that we just pushed was the main Node.js client, right? So I'll select that, and it was uploaded 1 minute ago. So I'll select this image, and I'll click on select. Again, I will give it a service name, which is main Node.js client. The region, I'll select it as Mumbai, but please select the one which is nearest to you. The service with the name already exists, so I'll just add the suffix as MLS because I already worked on this previously before the stream as well. So that might be the case with this, for which the service already exists. So the CPU is already allocated during post. I do not want that, as I already mentioned. I want my application to be up and running and ready to solve the traffic whenever it's needed, right? Otherwise, I do not want a cold boot up time for my applications because that might increase the time uh, from the request that the user sends to the response that they get, because the Cloud Run service would need some time to start up. So I'll just keep the CPU is always allocated option as checked. And also auto scaling, I want the minimum number of instances to be 1. And depending on the traffic, let's say if the traffic suddenly increases to a large number of people, then the application would be able to handle all the traffic if I enable the auto scaling option. For the ingress, I will keep it as all because I want the traffic to be, or the application to be available to the internet. So I will mention the ingress control as all, and authentication again, since this is a public website, I will click on allow authenticated invocation. So for the configurations, we don't need much configurations over here except from the port. So we do not have any environment variable that the client expects over here, so we don't need to provide that. But for the port, let us go ahead and check the port that the container is listening on, right? So for the front-end container, you can see that the container is using Nginx image, right? And if you go to Nginx configuration, you can see that the Nginx is listening on port 8080. So that's the port that we would need to provide on our image. So let us go ahead and do that. So on the port, I will mention the port as 8080, which is already present over there. And let me go ahead and start the container. So let us wait for this to complete. And once we have this, our application should be accessible from the web. And there we go. You can see that the deployment is complete, right? And we get the URL for our application. So if I click on the URL, you can see that the application loads, right? And you can already see 2 of our employees list. This is a simple employee management website where you can add a new employee, edit or delete them. So basically the CRUD operations for the employees. So you can do that. I already inserted this data in the database earlier before the stream. So that is how you will able to see the data. But for you, if you are doing this on your own, then you would not see this employee list and it would be empty for you all. So that means that we have successfully deployed our main stack application. We have created an image for our backend. We have deployed that. We have connected that to the MongoDB database. And now we have also deployed our front end, the client application as well. So let us go ahead and just try to delete some of these. So let me go ahead and delete Harry. I'll try to add a new one. Let us say as John. and John is, let's say, our analyst, right? And let's say he's a junior analyst, and I'll click on add. You can see the data is inserted right over here. Why don't I just mention the link in the comment itself so that you all can check that out? You all can access this application right now. So if you go ahead and copy the link on your browser, you would be able to see the application. And please go ahead and add some of the dummy employees on the website as well. I do want to see some of the random names over here as well. So go ahead and do that. And I'm more than happy to help you out. So right now we have configured our main stack application, but like I was saying, I want to automate the entire deployment process, right? Because right now, let's say if I want to change some of the code in our front end or back end, let's say I want to add a new feature or I add a new route on my API, I would need to build the Docker image again using all the Docker commands that I just showed you. I need to build the Docker image, I need to tag it, I need to again push it to the container registry, and then I would need to create a new revision. You can see that there is an option to deploy a new revision for our cloud services. So if you go ahead and click on that, it will again ask you for all the details like it asked in the first stage, right? So I would need to select the container image again, and then I would need to select the port. So I would need to configure all the settings, right? So that is a lot of work to do. So then that is a lot of manual tasks to do, which we do not want. I just want to let's say I add a new feature on my front end, I add a new cool background color, or I add a new feature for my front end. Then I just want it to uh, be deployed automatically, and we can use Google Cloud Build with GitHub to achieve that. So as a developer, what I would do is that I'll just make some changes in my application code. I'll just push it to GitHub, and then Google Cloud will automatically get the code from GitHub, and it will use the Docker file which is present in the repo to build a new Docker image, and then automatically use that image to deploy our Cloud Run service. And that is the beauty and magic of automated deployment. We also call this as a CI/CD pipeline in the DevOps term. So whatever changes we make as a developer, we just need to push it to the GitHub repository, and then since GitHub repository will be linked to Google Cloud Build, so that's the service that will build the new image automatically. So all the steps that we did manually, remember Docker build, Docker tag, Docker push. So Google Build will do all of that for us automatically behind the scene. We do not need to worry about that. And then it will use that image to run a new version of our Google Cloud Run service. And that's the beauty and magic of CI/CD pipeline. So let's go ahead and see that. Rasmi has said that they have added a new employee. So let us go ahead and refresh this. And you can see that we have a new uh, employee name over here. We also have Subham, full stack developer, and they at the junior level. So that means that our application is up and running fine. So let me set up the automated deployment now and show you how you can do that. You can see that in the repo that I have over here, there is the Beatstack application, and you can see that the code is present over here, right? So once you do that, let us go ahead and add some of the changes in our application code. Before I do that, I just remember that you need to have a few things enabled on your Docker cloud on the Cloud Run service. So for that, let us go ahead and click on set up a continuous deployment option, right? So you can see that right towards the right of edit and deploy new version, you can also see the option to set up a continuous deployment. So click on that. And once you click on that, you would be able to select the GitHub as the repository provider. Please make sure that you select GitHub over here. And then from the repository, please select the repository which contains your application code. So I have already connected my Google Cloud account with the GitHub GitHub and allowed it to get all the access to my repository. But if you're doing this for the first time, it will pop you up and take you to Google to take you to the GitHub account, and you need to sign into your GitHub account and allow permission for Google Cloud to access your repositories. So you need to do that and click on the repository once you connect your application. So I will select the one. So it was main stack example cloud, and I can select the repository over here. Before that, if you are not able to get this, I just want to showcase you the images of how it would look like. So just a second, and we refresh this for you all. I am pretty sure I have mentioned the image over here. So you can see that once you click on connect to the GitHub account, you will be prompted up with such pop-up. So you need to continue and allow the Google Cloud Build service to access different repository. And then once you do that, you need to install the Google Cloud Build application on your GitHub account. And once you do that, you would then be able to get the list of repositories over here. And now I'll click on advanced option. So I don't need to select the cloud source repository as my mirror. So if you also want the Docker image to be stored on your Google Cloud account, you can do that, but you do not want to do that in this case. And now on to the next, we need to select the Docker file path, right? So remember in the GitHub account that we have over here. So let me come back to the GitHub account. So remember in the GitHub account, we have two Docker files, right? So one was for the client and the other one was for the server. So let us first try to set up the automated deployment for client, right? So the path for Docker file for the client is inside the client folder, right? So we need to provide that path over here. So the Docker file for client is inside the client folder, while the Docker file for server is inside the server folder, right? So we'll just do that. So since this is for the client application, as you can see, I will select the source location as /client, and then the Docker file name is Docker file itself, and that should be good to go. I'll click on save, and that will set up the cloud build trigger. In the meantime, while this is being triggered and doing its thing in the backend, I will also set up the automated deployment for our backend server. So we did for the front end, and now I want to do that for the backend as well. So I'll set up the continuous deployment. And again, in the repository, I'll select the repo that we just created. So I'll go to the repository and I will click on the repository that we just used. And again, I'll use Dex. And here for the server, since this is for the server, remember the server Docker file is inside the server folder, right? So I'll just provide that and click on save. And this will set up a pipeline on our the GitHub account. So let us go ahead and check that. So if I now come back to the main stack cloud application, you can see there is a yellow dot beside the commit name, right? So this represents that there are two Google Cloud Build process that is being run, and you can get the details over here. So I'll open the details for both in the new tab, and you can see that both the service are being run and it's in the progress stage. It started 1 minute ago, right? So this is setting up a pipeline so that whenever there is any change to our application code in the GitHub repository, it will automatically trigger this pipeline that will build the Docker image based on the Docker file which is inside the repo, and then it will create a new image, and Google Cloud Run will use that image to update our application. So let us wait for this to complete. First, we need to wait for both of these to complete before we are able to see the automated deployment in action. So before that, if you have any questions, please let me know about that. Let me go back to Google Cloud Run, and while this is being set up, you can check the logs as well while that is being deployed once it is done. So I'll just wait for this to complete. I'll open the client as well as the server in the new tab. We need to wait for the deployment to complete, right? So if you want to see the logs, you can see that it is currently building and deploying from repository, right? So you can click on logs, and here you will be able to see the live build logs of how it is building the application. So you can see that it has 3 different steps. So first one is the build step, where it will build the Docker image, and then it will push the Docker image to the artifact repository automatically. We do not need to handle that. And then finally, once we have the image, it will deploy this to Google Cloud Run service. All of this happens automatically, and we do not need to type in the Docker command that we would normally do. And like I was saying, the build process is now completed, and you can see that it is using my GitHub repo as the source from the main branch, and it is using the latest commit, which was 7.2ca, to build the Docker image out of it. So you can see that the latest commit, if I go back to my application, you can see that the latest commit was 7.2ca. So whatever the code is there in my GitHub repo as of now, that is being used to deploy our application. And I will also show you how you can update your application and see the new version over there. So let us wait for the final build process to complete, and you can see that the build for our server is also complete. You can see the build ID, the start time, the end time, the duration, and the message over here as well. The build, push, and deploy stage. So 3 steps are succeeded. Now let us actually see the magic of Google Cloud Run, because that is what we want, right? So whenever we want to make any changes to our application code, Docker image should be built automatically out of it, and it should be reflected on Google Cloud Run and our application, right? So let us go ahead and see that. So which one would you want me to change, front end or the back end? Because since we have set up the pipeline on both front end and back end, it would work on both. So let me know which one should I change. I'll wait for a couple of seconds for you to answer, and then I will go with my gut feelings. Okay, so let us go with the client, and let us change the client side code, right? So let me go ahead and change one of the route. Which one would you say? Let us go to the employee list route, okay? And what do I want to change? Let us go to the add employee route, and here right now it says register a new employee whenever we want to add a new employee, right? So let me quickly go back and check that. So if I refresh this, uh, we can see that. So we also have Douglas as an engineer over here. Okay, so Subham also mentioned that we want to change the front end code, right? So let's go ahead and do that. So whenever I want to add a new employee, right now it says that register a new employee, so that's the text that is being displayed, right? So let us go ahead and change that. What do you want me to say it? Add a new rockstar employee. So that is how we want to say or name the new employee registration form, right? So we have changed the text, which now says add a new rockstar employee instead of register a new employee, right? So does that sound like a cool name or a cool phrase? So let us go ahead and just commit these changes. Okay, so I will just come to the I'll just come to the source code over here, and then what I will do is I will commit these changes right here, and I will click on the source code, and then I will update it the name. I'll give it a commit message. Before that, let me just verify if the link is right. I'm not so sure if the employee service link or the backend link was correct. So this is the link that is over here, and I just want to make sure the link is the right one. So this is the link that I'll copy, uh, and let me paste that. Okay, it was the same, so I do not need to worry. So now I'll go ahead and commit added new phrase, and then I'll just commit this using the source control from VS Code. You can also use the Git commands if you are familiar with that, and click on Sense sync changes, and this will push the changes to our uh, GitHub repo. So let's wait for this to complete, and then you will be able to see the real magic of Google Cloud in action. So seems like the push process is complete, and let me refresh my repository. And you can see that the new commit is over there, which says that is new phrase. And you can see that the Google Cloud process is already being ran here. You can see not one, but actually four different cold wait process, because I already created two before the demo. So that was already there beforehand, but these two are the ones that we created right here in the demo. So let us wait for this to complete. You can check the logs from the cloud build itself. So if I click on refresh, you can see that the building and deploying from repository is pending. So we can check the logs from here, right? And also for the client, we can do the same thing. I'll just close that. So that was for the server, and I will also do that for the client. Let us check the logs for the client as well. You can see that both of them are pending now. So this is the server logs, which is pending. You can see that the build process is being held. So it will take some time before the build process is complete for both the front end and the back end. And we will be able to see the updated version of our application once this build process is completed. So let us just wait for that to complete, and we should be good to go with this session. Please let me know if you have any questions in the meantime. I'm super happy to see all the names that you are putting over here. Yep, exactly. That automations happen when I push the changes or commit the changes into the main branch, or you merge it into the main branch if you are using the PRs. So you can also set up the pipeline to be triggered from any other branch. But by default, whenever you set up the automated deployment from Cloud Run using GitHub, it will use the main branch, but you can also configure it to use any other branch apart from main. So I can quickly show you that as well. So let me go back to one of the Cloud Run service. Cloud Run, that's a really good question, by the way. So let me go to Cloud Run, and if I go to the client MLS, right? So when you set up the right now it's being triggered, so we can't edit the deployment. But if you were to edit the deployment over here, once this is completed, and then in the repository that you would select, you would also be able to write the name of the branch that you want to use to trigger the deployment. So that's how you can do that. So you can see that the uh, pipeline trigger is also about to complete. Let us wait for this to complete. So it will build both front end and back end. Event changes only apply to front end. Yeah. Okay, let me make this clear. Yes, right now, since you have pushed any changes to the repo, right? So whether it could be on front end or back end, the pipeline will be triggered twice, one for the front end and the back end. But since the changes is only made to the front end code, right? We did not change anything on the back end. So back end would stay as it is. It will just be redeployed with the same version, but the content of the front end is what would actually change. So yeah, you will get the new the pipeline would run twice for front end and back end, but since we only modified the front end code, that's the only one that would get changed. Cool. So let us wait for this to complete. We might get some errors, and I'm super happy to debug the error if we get along. Let us wait for this. Let me see if that is running. So you can see that the client is already deployed. The latest one happened just a couple of minutes ago. Or we can also check that from the GitHub repo. Oh, GitHub still says it's running. So let me refresh that. So you can see that one of the build was failed. I do not worry about that, but 3 of them had succeeded. So let us see if the one that we actually deployed, it succeeded or not. So the one with the suffix of MLS were the ones that we deployed in this session. So first let's explore one, and you can see that the build is succeeded, and likewise for the client, the build is succeeded as well. So let me go to the URL of the client now. And now if we try to add a new employee, you can see that we have the Rockstar employee over here, right? I might have messed up some of the CSS while adding that text. So that is why you can see the as2 flag, but here you can see that the changes were reflected, right? So let me go ahead and add a new name. So this would be Mary. And I am pretty sure that I must have messed up some of the syntax over there. So that is why the CSS is looking bad over here, but I'm good with that as well. Let me add the position, but let us add them as the manager, and the position would be senior, and that would be added, and you can see that the employee is added over here. So you saw the power of GitHub as well, and how we can automate the deployment process, right? So now that whenever we make any changes to our application code, we just need to push it to the main branch. And once we do that, the pipeline will automatically be triggered. And whether you make changes on the front end or back end, if you made changes to both the changes will be reflected. Or if you made changes to the either one, only that would be reflected. But remember that pipeline will be triggered for both of them. So that is all done, and we have completed all the things that we have intended to do in this session. So remember the things that we did in the session today. So uh, we set up a MongoDB cloud on MongoDB Atlas, and then we used the credentials of that database and configured that in our backend service that we created. And we use the URL of the backend from Cloud Run to set up the front end client, and then we created an image for our front end, and then we uploaded that image to Google Cloud Artifact repository, and then we finally ran the Google Cloud Run for our front end, and that is how we were able to access the application. And then we also created the pipeline using Google Code Build, Cloud Build to automate the deployment process, so that whenever we have any changes to our application repo, the pipeline would get triggered, and the new version of our application would get automatically deployed. So before I leave you off, I also want to showcase you the really cool feature of Google Cloud Run, that is the integration of custom domains. So if you go to the integrations tab, you can add a new integration. So you can create a new integration, and from here you can add your own custom domain name as well. So right now, my custom domain name is already added. So I did that before the session. So this was the domain that I already had. So amazing dash hackface dash club. So I can show you that quickly as well. So if I go to this URL, you can see that the same application that we just deployed is also present in this link. That is because I already added the custom domain, and that is super easy to do. So I'll show you the process as well. So if you go to the integration tab, the first thing that you need to do is to add your custom domain over here and make sure that the path is set to slash. That is the home path of your application. And then you need to add a record on your domain provider. So let's say you purchased a domain from Namecheap, GoDaddy, or any other domain registry. By the way, you could get a free domain name for your application in MLS hackathons and in different MLS Global Hack Week events. So make sure that you check out for those and participate in MLS events to get a free domain. So I got one in one of the hackathons earlier, and I can quickly log in to the domain provider to show you the steps. So let me log into my domain provider account. That I'll just quickly do that for you all. And once I log in, the only thing that I need to do to set up a custom domain is to, like I said, add this record on the domain provider. So the name for the a record type, and I need to provide the value. This is the IP of the Google Cloud Run that I need to add in the for the porkboard account, which is the domain registry for my domain name. For some reason, my domain name is domain provider is not being loaded. I do not know why. You can see that. I can show you that. Uh, the site is not being loaded. It might be down for some reason. I'm not sure why. But like I said, the only thing that you need to do over here is to log into your domain name provider. Just log into Namecheap or your GoDaddy account or any other provider that you are using, and there would be an option to add a record for your domain name. Just type in the name as the link for your domain name. Give it a TTL value of 3600 seconds, and the type record should be A, and you can point the uh, domain to this specific IP. This is the IP of the Google Cloud Run, and make sure that you configure the custom domain name in the front end or the client application, because that is the way that people would access your application. You do not want to configure custom domain for your backend. You would only want to do it for the client or the front end, right? So let me wait if the port one is loaded, and seems like it's not. So yeah, seems like there is some issue with the port one itself, and that is why it's not loaded. I guess they have some server side issues. That's not the issue on our side, so do not need to worry about that. You can see that the domain is active, and once you configure that and click on update, it will even install SSL certificate so that all your requests are encrypted. So you will also get the SSL certificate with the Google Cloud Run, and I can quickly show you that with the URL of my application. So if I go to integration again here, not that. So if I go to the site over here and in the integration tab, you can see that this was the version of my application which I already deployed earlier. So this is the domain that I purchased, right? So if I click on the domain, you can see that the website loads, and this is the application link. I will also post that on the comments. So if you want to browse that, you can do that. So the only thing that you need to do is to create a record in your domain name provider and point the IP that Google Cloud Run has mentioned, and you would be able to access your application. So that is all the thing that we discussed. And before I leave you off, I also wanted to share you some of the best practices that you can follow when building Docker images, and I have mentioned them in the repository as well. So if you go to Google's official documentation, you can see that Google has recommended some of the best practices whenever you uh, build your Docker images. So the first recommendation is to use multi-stage build. Remember, for the client application that we use. So if I can show you that quickly. So this was the Docker file, right, for our client. Uh, you can see that we are using multi-stage build because this is the first stage of our build process, and then this is the second stage. and the output from the first stage will be used as an input for the second stage. And that is recommended way to build your Docker image, especially if you have large amount of tasks that you need to do. So we just build the Angular application over here, and then only the artifacts or the required assets that we need to serve our static application is used by the Nginx server to serve those images. And that significantly reduces the application boot up time and reduces the image size as well. So that is one of the best practice that Docker recommends. We also exclude all the things that we do not need in the Docker ignore file, which we saw in the demo as well when we excluded the .env as well as the node modules. And do not install any unnecessary package in your application, and please do not try to make your Docker file very long. Try to keep it minimal. Try to decouple applications. So as far as I'm concerned, please do not and never combine both your front end and back end into a single container. That would be a super mess, and you do not want to do that in production as well. You want to keep your client and the backend separated, and you can also use multi-thread arguments to run different commands. Instead of writing multiple run instruction, you can just write a single run instruction, and that will keep the image layer to a minimal one. And there are a lot of other best practices as well that you can follow from the official Docker Hub repo. So, well, I guess that concludes everything. I guess we covered a lot of different things in this session. We deployed different versions of our applications. We saw how we can containerize the image. We saw how to push it to artifact repository. We even saw how to automate the deployment process and use a custom domain. Let me come back to the slide, right? So we saw everything about containers. We saw what containers images are, and then we learned about Docker. We saw how it is useful. We also discussed about the Docker architecture yesterday. We saw the different basic Docker commands for the container lifecycle process. We had a demo of building and deploying the Docker image. So that concludes all the things that we need to do in this demo. And if you are working to build wonderful solutions for your project, make sure to use Docker in your application now and submit that application, whatever project you are working, to the month-long hackathon that we are hosting this month. So we are hosting the MLS December month-long hackathon for you to submit your project. So since you all just learned about Docker containers and how you can deploy that to Google Cloud, so you are now equipped with all the knowledge and skills required to containerize your application and deploy it to Google Cloud. We have a lot of amazing partners and prizes that you can win as well. So make sure that you submit your project into those categories, and you might win some amazing cool prizes as well. So make sure you check that out and submit your project before the end of this month. And thanks once again, everyone, for joining in. I hope that you all enjoyed this session. It was a lot to cover, but I am hopeful that you all learned something new in this session that we did yesterday and today. And I will see you again in the next one. If you have any questions, feel free to ask me in the chat right now, uh, or in the social media that I shared you earlier. I'm happy to connect with you all as well. So before I leave off, we have one final query, I believe. Can you recap the MongoDB setup? Sure, I can do that for you. For MongoDB, what you can do is to go to the uh, MongoDB console from the Google Cloud Run. So search for MongoDB from Google Cloud Console, and you'll be able to find the MongoDB Atlas from here. And from here, you just need to sign up for a MongoDB Atlas. Since I already signed up for a MongoDB Atlas, it's not asking me to sign up again. But if you're doing this for the first time, it will ask you to sign up for the MongoDB Atlas. And once you click on provider, it will take you to the MongoDB Atlas website. So it will redirect you to the MongoDB Atlas website, and you need to log in to your account. Give it a second. And once you log in, you just need to create a new database. That's a pretty simple 3 or 4 steps that you need to click. So just go to database section. And then once you click on database, you can create a new database from here. And you will be using the username and password that you use to create a database. And once you use the username and password to create the database, you can click on connect. And once you click on connect, here you'll be able to see the database link. And that is the link that you need to configure in your Cloud Run service. So go to the Cloud Run service, and when you set up your server, uh, for the first time, you need to provide the environment variable, right? So under the variable section, you need to provide the value that you just copied from the MongoDB URI. So you need to provide the value over here, and please make sure to replace the username as well as password with your actual username and password that you created, used to create the database. And then once you click on save, that would be good to go. So that's the only thing that you need to do. Make sure that the value for the environment variable is at class underscore URL. Cool. I hope that answers your question. So that is all that I have for you all. Rasmi says, really great and informative session. Thanks a lot and Merry Christmas. So, Merry Christmas to you all. So, I'll just quickly uh, close my screen. So, again, bye bye, everyone. Very happy holidays, and I will see you in the next year. So, bye bye, everyone. Have a great time, and I'll see you soon.